In Lesson 9.3, you will represent linear functions using function tables and graphs. Example 1 says the school store sells book covers for $2 each and notebooks for $1. Tony wants to buy some of each. The cost of X book covers and Y notebooks is 2X plus Y. Tony has $5 to spend, so 2X plus Y equals 5. Graph 2X plus Y equals 5 to find how many covers and notebooks Tony can buy. The equation is 2X plus Y equals 5 because each book cover is $2, so $2 times the number of book covers, plus the notebooks are $1, so $1 times the number of notebooks has to equal 5. Now if we want to make a function table, we're going to want to take this equation 2x plus y equals 5 and solve it for y, because we want to be able to plug in something for x and see what comes out. So it's best to have it solved for y. We're going to do that by getting rid of this 2x by subtracting 2x from both sides. So on the left side, this is going to be 0, which means you're left with y, equals. Now over on the right, these are not like terms, so they cannot be combined. You're just going to write 5 minus 2x. Now to make the function table, you're going to make a table like this, and what we just came up with, this 5 minus 2x, is going to go right here. This is the column for our work. So we have what we plug in for x, what comes out y, and then the ordered pair that's going to be graphed. So I chose some numbers for x, 0, 1, 2, 3. Remember, x represents the number of book covers, and y is the number of notebooks. So you're going to plug in 0 for x, 5 minus 2 times 0. Well, 2 times 0 is 0, and 5 minus 0 is 5. So then the ordered pair is 0, 5. You could get 0 covers and 5 notebooks. Now plug in 1. 5 minus 2 times 1, we replace the x with a 1. 2 times 1 is 2. 5 minus 2 is 3, so the ordered pair is 1, 3. Plug in 2. 2 times 2 is 4. 5 minus 4 is 1, so the ordered pair is 2, 1. Now if you buy 3 covers, it's 5 minus 2 times 3. 2 times 3 is 6. 5 minus 6 is negative 1. So the ordered pair would be 3, negative 1. Now when you go to plot those ordered pairs, remember the x value tells you how far right or left to go, and the y value tells you how far up or down to go. So to plot 0, 5, you stay at the origin and go up 5. To plot 1, 3, you're going to go to the right 1 and up 3. To plot 2, 1, you're going to go to the right 2 and up 1. And then for 3, negative 1, you're going to go to the right 3 and down 1 since it's negative. Now this is not a possibility because you can't buy a negative number of notebooks. So here are all the possibilities. You could buy 0 covers and 5 notebooks, 1 cover and 3 notebooks, or 2 covers and 1 notebook. Now one might argue that this isn't a possibility either because it says she wants to buy some of each. Well, this would be 0 covers, so that one really doesn't fit either. So really we're looking at these two. You could buy 1 cover, 3 notebooks, or 2 covers and 1 notebook. Notice these points all fall in a straight line because we're talking about linear functions today. Linear functions are functions that are in a straight line. Example 2. Graph y equals x plus 2. This piece right here is what we're going to plug in here. That's our work column. We're going to go ahead and plug in some numbers for x. I'm going to go ahead and plug in some negatives and positives. So I'm going to go from negative 2 to 2. So negative 2, negative 1, 0, 1, and 2. If I plug in negative 2 for x, it's negative 2 plus 2. Negative 2 plus 2 is 0. So the ordered pair is negative 2, 0. If I were to plot this one, I would go to the left 2 and then stay right there. Now I'm going to plug in negative 1 for x. Negative 1 plus 2. Negative 1 plus 2 is 1. So the ordered pair is negative 1, 1, which means we're going to go to the left 1 and up 1. Now I'm going to plug in 0 for x. 0 plus 2 is 2. So the ordered pair is 0, 2, which means I'm going to stay at the origin but then move up 2 units. Now I'm going to go ahead and plug in 1. 1 plus 2 is 3. So the ordered pair is 1, 3, which means I'm going to go to the right 1 and up 3. And now I'm going to plug in 2. 2 in place of x. So 2 plus 2 is 4. So the ordered pair is 2, 4, which means I'm going to go to the right 2 and up 4. Now you'll notice that those points all fall in a straight line. I'm going to go ahead and connect them with a line. I didn't connect my points in the first example because you couldn't buy half of a notebook or half of a book cover. But since there is no context attached to this equation, we could plug in any number we wanted for x, including fractions and decimals. So it is also including all these points in between the ones that we plotted. So when we connect it, we have a line like this. Technically, you only need 2 points to make a line, but we're going to make our table with more points so that way we can notice if we make a mistake somewhere. When we're all done plotting the points, they should be in a straight line like this. A function in which the graph of the solution forms a line is called a linear function. Therefore, y equals x plus 2 is a linear equation or a linear function. You may want to pause the video and try the next one on your own. Again, this part right here, whatever y is equal to, goes right here for our work. 2x plus 1. I'm going to go ahead and plug in some numbers such as negative 2, negative 1, 0, 1, and 2. Now we're going to go ahead and plug those in. 2 times negative 2 plus 1. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So the ordered pair is negative 2, negative 3. Now when I plot that, it's going to go to the left 2 and down 3. Now when I plug in negative 1, it's 2 times negative 1 plus 1. Well, 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. So I'm going to plot the ordered pair negative 1, negative 1, which means I'm going to go to the left 1 and down 1. Now I'm going to plug in 0 for x. 2 times 0 plus 1. Well, 2 times 0 is 0, and 0 plus 1 is 1. So the ordered pair is 0, 1, which means I'm going to stay at the origin but then go up 1. Again, since we're talking about linear functions, as you're plotting these points, they should be going in a straight line, and it looks like they are so far. Now I'm going to plug in 1 for x. So 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. So the ordered pair I'm going to plot is 1, 3, which means I'm going to go to the right 1 and up 3. And the last one I'm going to plot, I'm going to plug in 2 for x. 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So my ordered pair is 2, 5, which means I'm going to go to the right 2 and up 5. And again, since there isn't any context with this equation, we could have numbers that are fractions or decimals as well. So I'm going to go ahead and connect these points with a straight line. We put arrows on the ends to show that it keeps going in both directions. And basically what this means is if I were to pick any point on this line and plug it into this equation, it would work. It would be a solution to this equation. Our last example says which line graph below best represents the table of values for the ordered pairs x, y. And we have 4 choices here, so I'm going to just go ahead and start looking at these ordered pairs. -2, -3. -2, -3 means to the left 2 and down 3. So it should be right there, and that is not on that line, so it's not going to be A. Let's try B. -2, -3 would be right there. Again, not on the line, so that is not going to be the solution. Let's try C. To the right or to the left 2 and down 3. That one is on the line. Now let's try -1, -1, which is to the left 1 and down 1. That one's also on the line, so I think we found our solution, but let's just keep checking. 0, 1 means stay there and go up 1. And then 1, 3 means to the right 1 and up 3. We found our winner. C is the correct answer.